Assalamualaikum and a very good day to all viewers. We are from Group 5 from Section 2. We would like to present our project called Electromagnetic Train. So basically, in this project, the neodymium magnets on the ends of battery create like pole facing outward. When put the train inside the coils, it causes an electric current to flow through the copper wire, which creates a magnetic field in the section of wire coils right around the train. So our project it will be like this. So the objectives to our project are to build an electromagnetic train made of a battery and magnet that propels itself through a coil of wire using magnetic force. Then implement the basic principle of electromagnetism and engineering.
In this experiment, we just need three material. The first material is the magnet. This magnet have thickness of 5 mm and diameter of 15 mm. We need two magnets for this experiment. Then the next one is the battery. This is a AA size battery. We just need one battery for this experiment. Then the last material is the bare copper wire. We need to coil it with a 15 mm diameter rod.
First, the pole of the magnet is determined. Next, the spring is then coiled up and form a track. Then, the magnet is attached to the battery with the north pole facing outward. After that, the train is then inserted into the spring coil and make sure both the magnet is touching the coil. Next, one side of the pole of magnet is reversed and observed. Lastly, both sides of the pole of magnet is reversed and observed.
Now let me explain how this electromagnetic train works in detail to give you a clearer picture. Electromagnetism is a process where a magnetic field is created by introducing the current in the conductor. Using this concept, a solenoid coil can be a temporary magnet when there is current flowing in the coil, and the pulse of the magnet can be determined using right-hand grip rule. Let's look at the electromagnetic train. We will put it into a simpler diagram. So this is the battery, two neodymium magnets. Please be noted that the magnets should have light poles facing outward, either N with N or S with S. Then we place it into a solenoid. The current will flow from the positive end of the battery through the nickel-plated neodymium magnets, which is electrically conductive, then passing through the copper wire, then back to the negative end of the battery. So by using right-hand grip rule, we can identify this end is south pole while this end is north pole. As light pole repels, the magnet on the left is repelled to the left by the magnetic field generated by the solenoid, while the magnet on the right is attracted to the left due to the north pole generated by the solenoid. Together, they will push the battery inside the solenoid and the battery will move to the left continuously. If we flip both magnets, then the battery will move in opposite direction. Let's see. Okay, we flip the magnets, and this time, the magnet at the right will be repelled to the right, and this end will be attracted. Therefore, the battery is now moving to the right. And what if we have a light pole facing outwards? Let's see. Okay, now both magnets will be attracted to the poles of the solenoid. We no longer have repulsive force, therefore the electromagnetic train will not move.
Okay, conclusion from our group. The objectives are achieved and we successfully built an electromagnetic train using the concept of electromagnetism and magnetism. From the experiment, we got some suggestions before doing the experiment. First, make sure the copper wire must coil properly to prevent the train stuck in the copper coil. The second, if the battery stuck inside the coil, we must take it out soon as possible because the temperature will keep rising in the coil. For the real potential on our experiment, we took an example from maglev trains. Few countries use powerful electromagnet to develop high-speed trains called maglev trains. They use basic magnetism, which are attraction and repulsion. They create a unique system of magnetic field on their guideway walls to pull and push the train along the guideway. The electric current supplied to the coils in the guideway walls is constantly altering to change the polarity of magnetic coils. This change in the polarity causes the magnet field in front of the train to pull the trains forward. Thank you.